Okay, so we're going to be getting into scientific notation and powers of 10. So the biggest part of scientific notation is being able to write huge numbers in a very simplistic way, as well as very small numbers in a very simple way. And by doing this, we can use powers of 10. So if you've ever noticed, to get from 10 to 1,000, we can just multiply by 100. The number 100, if we think about it, the number 100 is technically 10 squared. It's 10 times 10. So to get from 10 to 1,000, we essentially are multiplying 10 by 3, because we're taking that 10 and we're multiplying it by 2 more 10s to get us 3 total 10s. 10 times 10 times 10 will get us 1,000. So we're looking at how we can move up and down a number line in tens essentially, and make that easy for us. So if we think about this, let's look at this table and look at some specific patterns. Essentially, this first table that we have here, if we look at the top of it, to get from 10 to the third down to 10 squared, we essentially are dividing by 10. So that third to the second is essentially telling us that we're dividing by 10. We're getting rid of one power. Essentially, 10 to the third is 10 times 10 times 10, whereas 10 squared is 10 times 10. So if you notice, we have eliminated one of those 10s to get down to 10 squared. Same for 10 to the first, same for 10 to the 0, that's essentially 1, and so on. And we're going down and down and down, so we get into decimal numbers. Then as well, we can look at the values here. We're essentially just knocking off a 0 every time. If we want to look at 1,000 and get it to 100, we're knocking off a 0. We're dividing by 10. We can also think of it in the other direction as multiplying by 10 to get bigger and bigger and bigger. We are essentially adding a 0. To get from 1 to 10, we're adding a 0. We're multiplying by 10. To get from 10 to 100, we are multiplying by 10. We're adding a 0. Okay? Simple idea, and yet at the same time it can be very complex if we aren't super aware of what is going on. All we are doing is multiplying or dividing by 10 when we're dealing with this whole chapter. So let's go on and look at the first part of this chapter. We're just looking at the integers. So when we're looking at the integers of these things, let's look at this first part. We're just talking about exponents. If we have something written as 10 to the 4th power, I want you to think of that as taking the number 1 and moving its decimal point, which we know is just to the right of that number 1, and we're moving it over 4 places. And if we were to do that, we are going to fill it in with a bunch of zeros. It's new decimal places right there. Hence the 4th power, we've moved it over 4 places. If we've done that, we essentially have the answer of 10,000. Simple enough, right? So now let's look at this exponent, the negative integer exponent. Now we learned from the last chapter, negative exponents tell us that this number 10 is in the wrong place. The number that it is attached to is in the wrong place. It's either in the numerator when it's not supposed to be, or it's in the denominator when it's not supposed to be. We have 10 to the negative 6. 10 is currently in the numerator, so we can shove it down into the denominator and make it 10 to the positive 6 in the denominator. And we'd put a 1 over the top of it and have essentially a fraction. So 1 over 10 to the 6, that's another way of writing this number right here. We can essentially say the number 1. And we are going to move that decimal point over 1, 2, 3, 4, 5, 6 places. So we're going to put a new decimal point in there, and we're going to fill this in with all these zeros. So essentially, here is our final product. We have 1/100,000th is this whole concept of 10, or 1 over 10 to the 6, or 10 to the negative 6. That is essentially 1 to the negative 100,000th. So let's practice a couple of problems. Here is our first problem. Let's look at just some of these ones where we need to evaluate them. We need to put them into a big, huge number. We need to see how big that number is or how small that number is. So we have 10 to the negative 4th. 10 to the negative fourth. That tells me that I'm going to have a very small number. If it's negative, I can rewrite this whole thing as being 1 over 10 to the fourth. Okay, that negative told me that the 10 is in the wrong spot. I need to put it into the denominator because it's currently in the numerator. So if I do that, I have 10 to the negative fourth. If I write that, I can essentially write 1. And if you notice, I'm always writing 1 here. Why am I writing 1? Where am I getting that from? Well, there's no other number besides 4, and that 4 is technically an exponent, so it's not telling me that I have any other number besides this one right here, this 1 or this 1 right here. So we're just paying attention to that 1 in this case, okay? So we have 1 and we're going over negative 4. So I'm going to go 1, 2, 3, 4. Putting in a new decimal point, and I'm going to fill this in with zeros. How many zeros might I, or are you asking? Well, we have 1 taking care of one of these place values, and we have 3 more place values that need to be taken care of. So we can rewrite this entire thing as saying 0.000, 3 zeros and a 1. 1 tens, hundreds, thousands, 10,000. 1 10,000th is our answer for this 10 to the negative fourth. Here we go. Here's our next problem. We have 10 to the ninth. I like this 9 because it's not negative. That means the 10 is in the correct spot. It's in the numerator, and that's okay. So I'm going to start out with a 1. I'm going to put my decimal point in, and now I have to move that decimal point over to the right 9 places because I'm making this number bigger. This 9 is telling me that I'm making it bigger. That negative 4 was telling me I was making something smaller, but this time I'm making something bigger. So I'm going to move it over 9 places. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. Now I'm going to add in my zeros. Oh my goodness, it's a lot of zeros to add in. After that, to really be able to have an idea of what this number is, I'm going to add in the commas between my numbers, and it looks like I actually have 1 trillion as my answer. 1 trillion. That is 1/4 of our current national debt. That's pretty exciting. Actually, it could be even less than that. That could be kind of crazy. All right, so now we have to write each number as a power of 10. We have 1 million. We need to write that as a power of 10. If I were to write that as a power of 10, I need to look at the decimal point where it currently is, and I need to shove it next to that 1. So how many place values am I going to go over? I'm going to go over 1, 2, 3, 4, 5, 6. So I have 10 to the 6th. Big number, big number, big number. And here is our other problem. We have a small number. So if I think about this, I can technically, I know that it's going to be 10 and it's going to be a negative, or it's going to be a negative integer on the top, or for my exponent, because it's a small number, so it's going to be negative integer. And we're going to go over 1, 2, 3. 10 to the negative 3 is how I'm going to do that, and that's how that's rewritten, 10 to the negative 3. All right. Now we are going to look at some numbers that are not so pretty. They make it a little bit more difficult. This is straight out of your book. We are going to say, this is on page 453, multiplying by powers of 10. We have numbers that are not so pretty of 125 times 10 to the 5th. That's technically a 5 right there. Let's see if I can rewrite that as a 5. 10 to the 5th. So looking at that, all I'm going to do is I'm thinking about place, or where the decimal place is. The decimal place in 125 is right behind that 125, and so that's why we're going to then move it over positively. So we're going to make this number bigger, 5 place values. So we get, it looks like 12,500,000. More than Bill Gates's current net worth. So that's pretty intense. Let's actually make this a little bit smaller so I can also see my example problems afterwards. The next one, we have 36.2 times 10 to the negative 3rd. All right, so looking at that, my decimal point is between the 6 and the 2, so that is where I'm going to move things from. And I'm making it smaller because I have a negative 3rd going on, or negative 3 going on here. 36.2 times 10 to the negative 3. We are moving this 1, 2, 3 place values over. I'm going to add in a 0 before I put my decimal point. And so now we have 362 10,000ths. Pretty intense. Find the value of each expression. Let's try a couple of practice problems now. So we have 23.89, 23 and 89 hundredths times 10 to the 8th. If we look at this, we need to rewrite this as 23.89, and I'm rewriting it without that 10 to the 8th, so that way I can actually add in my place values that I'm doing. I have a positive 8 here, so I'm making this bigger. It's going to get bigger because it's positive, so I'm going to move this over 8 places. We have 1, 2, 3, 4, 5, 6, 7, 8. And now I'm going to add in my zeros. Okay? From there, after that, I have a new decimal point, so let's count every 3, and we're going to add in our commas. So I have, technically for my answer, let's look at this. This is thousands, millions, billions. 2.289,000,000. We could even say it's dollars. That's pretty exciting. That's a lot of money. The next, we have 467 times 10 to the negative 3. After that, let's look at this 467, and our decimal point is right there, and we are going to be moving it over negative 3, and that means we're moving it to the left. We are making this number smaller. We're moving it over 3 total places, 1, 2, 3, and we get 0.467. I believe we are now getting the hang of this. Please stick with me. We have one more little thing that we need to look at. Scientific notation. I know many of you have looked at this in science already with Mrs. Jurasic, but at the same time, let's look at it now for math. Scientific notation. The whole concept behind scientific notation is this is a method of writing numbers that are very large or very small. A number written in scientific notation has 2 parts that are multiplied. So if we look at these 2 parts, we essentially here have one part, 3.5, that's the number, or 9.98. That is the original number of something. It represents something. And then our second part is the times 10 to the negative, or 10 to the positive 11th, or times 10 to the negative 2. If I were to then write these numbers out, let's look at the number 3.5 times 10 to the 11th. We are essentially taking that decimal place and we are shoving it over 11 times. We're making this bigger because it's a positive 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, massive. This is huge. I hope I'm not missing any place values. So then we're going to add in our commas. We essentially have thousands, millions, billions, 350 billion. That's huge. 350 billion. All right, this next one we have 9.98 times 10 to the negative 2. So we can move this over 2 place values, and we end up having a new decimal point of 0.0998. So we have 998 10,000, or 998 10,000s. Let's try a couple actual problems. So I know you guys have been studying science and studying planets and that sort of thing, so let's look at Saturn. Saturn has a diameter of 1.2 times 10, oops, this should say to the 5th kilometers. Its distance from the sun is let's look at this, 1,427,000,000 kilometers away. So we need to write Saturn's diameter in standard form. Standard form essentially means that you're going to write it out with just basic numbers. There's not going to be a times 10 anything. It's just going to be all numbers. So we have 1.2, and it had 10 to the 5th before. So to represent that 10 to the 5th, we are going to move this over 5 place values. Adding in our commas there, we can see that its diameter is 120,000 kilometers. Look at that. I put the units on there. Make sure you put units on. Write Saturn's distance from the sun in scientific notation. So we have this original amount of 1,427,000,000 kilometers, and we need to write it into scientific notation. That means we are going to put our decimal point eventually between the 1 and the 4, because if we look back at scientific notation, the front part, this part is a number that is greater than or equal to 1 and less than 10. That means it needs to be between the number 1 and 10. It can't be anywhere in the middle of that. It needs to be between those two numbers. So 3.5 would work, 9.98 would work, but 35, that would not work for your original number. Or even if we had 10.1 as our original number, that is not correct. That wouldn't work for our scientific notation. So let's go back to our problem. So we're going and moving this decimal point in between the 1 and the 4 because that is between 1 and 10. 1.4 is between 1 and 10 if we look at this number right there. It's between 1 and 10. And we're going to move our decimal point from this location at the very end. So how many points do I need to move it? We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.427 times 10. That's our base form for scientific notation, and we move this over 9 place values. So that is our distance from the sun in scientific notation. Hope this helped.